In this example, we'll look at how to utilize the quadratic formula to solve for the x-intercepts of a quadratic equation. So you may remember when we have a quadratic, each one of our coefficients can be represented by a variable. The coefficient on the squared term is a, the coefficient on the linear term is b, and the constant is c. Once we have these values, we can plug them into our quadratic formula and simplify. So you'll notice that I've taken the variables and replaced them with their value. Now, this really is the easy part. The hard part is all the simplification and algebra that comes with it. So let's talk through that step by step. I'm always going to simplify what's in the radical first. So I'll rewrite what I have out front. 13 squared is 169, and then I'll be subtracting 4 times 3, which is 12, times negative 10, which is negative 120. Notice how I'm subtracting a negative, and I have that in parentheses here, but to help myself, I'm going to go ahead and change that to plus a positive. And that whole thing will be divided by 6. I'm still going to work inside and simplify what I have here under the radical before I go any further. 169 plus 120 is going to be 289. So now I have negative 13 plus or minus the square root of 289 over 6. The square root of 289 is 17. So I have negative 13 plus or minus 17 all divided by 6. Now we're still not safe from possible errors. Be careful because when you're finding these values, we need to evaluate the numerator first and then go ahead and divide by 6. So in our first one, finish writing this here, I have negative 13 plus 17. That's going to give me 4 over 6, which is 2/3. In my second example, I'll do negative 13 minus 17, which is negative 30, and negative 30 divided by 6 is negative 5. So I have two solutions to my quadratic, or two x-intercepts, one at positive 2/3 and one at negative 5.